Hey guys, Dr. Brown here, and tonight we're working the integral of x tangent squared x dx. Now you know the tools. We have u sub, trig sub, integration by parts, partial fractions, power reduction, long division, completing the square, and method of quadratics. And I think with this one, since we have two pieces to it, we'll use integration by parts. I think would be the best, but I want to make a trig transformation before I do anything. We know now we could do this with integrating like sine squared over cosine squared for the tangent, but let's just transform that to secant squared minus 1. So I have the integral of x, and tangent squared we know is secant squared x minus 1. Okay, we're integrating with respect to x. So now then, let me go through the integration by parts and choose the part I can integrate as secant squared x minus 1. That becomes a very simple integral, okay? So a DI method, we have a plus, minus, plus. Okay, we're integrating, choose that part first. Secant squared x minus 1. And we're integrating with respect to x. Okay, the other term, we're differentiating, and we're differentiating x. So there's three stops. You know, if you, in the derivative column, we'll just do that here. Derivative of x is 1, derivative of 1 is 0. That's a stop when you get 0. Now, if we went along here and we found, if we integrate, and we find, oh, I can integrate this row, that's a stop, okay? Or if this starts repeating itself, that's another stop. Those are the three stops using the DI method. Okay, let's integrate secant squared x. We know that to be tangent x, okay? And then the integral of minus 1 dx is minus x. So that became a simple integral there. Now let's integrate tangent x. Now we know tangent is sine x over cosine x dx, okay? Let's use a u sub now. U equals cosine x, du equals minus sine x dx, solving for dx because I have to replace this. So du over minus sine x equals dx. Sorry for the big crack in the board. Life is that way, isn't it? We have to learn how to step over the cracks in life. Same on our board here. All right, so now with integral, we have this sine x over u, or over cosine x, which was u, and then dx, which is du over minus, I'm going to put the minus out here, minus sine x. The sine x is canceled, and I'm left with minus the integral of du over u. So minus a natural log of u, which is minus natural log of cosine x. Okay, so in this case, minus natural log of cosine x. Now the integral of minus x is minus 1/2 x squared. So that's x to the first power, increase it by 1, which is 2, divide by that, okay? All right, so that now, since we have a stop, we're multiplying the diagonals as well as the signs of the diagonals. So what do we have here? We have x times tangent x minus x. That's a positive and a positive. Now we have minus 1 times, so a negative 1 times negative natural log cosine x is a positive natural log cosine x. then a negative times negative, so it's plus 1/2 x squared. Now we're integrating the row. 0 times that, the integral, that's 0 for our purposes. So let's distribute x tangent x. So x tangent x, x times negative x is minus x squared, plus natural log cosine x plus 1/2 x squared. So I have a negative x squared and a positive 1/2 x squared gives me minus 1/2 x squared. So I have x tangent x minus 1/2 x squared plus natural log cosine x plus c. And that, my friend, would be the integral of x tangent squared x. And in the next video, we'll take the derivative of this to make certain that it's the correct answer. All right, that's all for now. Keep studying. Why are we doing this? We say it every week. Together, we're trying to build a better tomorrow through math. Keep studying. We'll talk to you next time. Thanks.